Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of vector addition. So as per the problem, the cube is constructed from three vectors A, B and C as shown below. So vector A, vector B and vector C. Express each of the diagonals AG, BH, CE and DF in terms of vectors A, B and C. So let's start with part A. So the first diagonal is AG. Now vector AG goes from point A to point G. Now an alternate route for going from point A to point G is to go from A to B, then B to C, and then from C to G. So we can break up vector AG as now vector AB is equal to vector A. And vector BC is equal to vector AD because they have the same magnitude and same direction. And vector CG is equal to vector AE because they have the same magnitude and same direction. Now we are given that vector AD is equal to vector B and vector AE is equal to vector C. So this should be the final answer for vector AG. So now we can analyze vector BH. Now vector BH goes from point B to point H on the cube. Now an alternate way to go from B to H is to go from B to C and then from C to G and then from G to H. So we can break up vector BH as now vector BC is equal to vector AD because they have the same magnitude and direction, and vector CG is equal to vector AE because they have the same magnitude and direction. Now vector GH is opposite to vector AB because GH is going from right to left and vector AB is going from left to right. So we can write vector GH as minus vector AB. So there is a very important concept we need to understand and memorize. Now AD is equal to vector B, vector AE is equal to vector C, and vector AB is vector A. So we can rewrite this expression as so this should be the final answer for vector BH. Now we can analyze vector CE. So vector CE goes from point C to point E. So an alternate way to go from C to E is to go from C to B and then B to A, and then from A to E. Now vector CB is the opposite of vector BC, and vector BA is the opposite of vector AB, and vector AE is given as vector C. Now vector BC is equal to vector AD because they have the same magnitude and direction, and vector AB is given as vector A. Now vector AD is equal to vector B. So we can rewrite our answer as, so this should be the final answer for vector CE. Now we can analyze vector DF. Now an alternate way to go from point D to point F is to go from D to C, C to G, and then G to F. Now vector DC is equal to vector AB because they have the same magnitude and direction, and then vector CG is equal to vector AE because they have the same magnitude and direction. Now vector GF is opposite of vector FG. Now vector AB is given as vector A, vector AE is given as vector C, and vector FG is equal to vector AD because they have the same magnitude and direction. Now vector AD is equal to vector B. And now we can rearrange the terms. So this should be the final answer for vector DF. Now we can answer part B. Is magnitude of vector AG equal to magnitude of vector BH? Explain. So here we'll have to use Pythagorean theorem to figure out if these two vector magnitudes are equal to each other. Now we are analyzing a cube here, and we know that in a cube all sides are equal in length. So that means the magnitude of vector A is equal to the magnitude of vector B which is also equal to the magnitude of vector C. And let's assume they all are equal to x. So x here represents the side length of this cube. Now we can analyze the magnitude of vector AG. Now the magnitude of vector AG means the length of the diagonal from A to G. Now if we draw a straight line from corner A to corner C and join points A and G, we get a right angle triangle. Now we can use Pythagorean theorem to write a relationship between the lengths of this triangle. So as per the Pythagorean theorem equation, c square equals, now c represents the length of the hypotenuse. In this case, it's the magnitude of vector AG. And A can represent the magnitude of vector AC. And B will be the magnitude of vector CG. Now AC is the hypotenuse of triangle ABC. So we can replace the magnitude of vector AC square using the Pythagorean theorem equation for triangle ABC. So for triangle ABC, so ABC is a right angle triangle. So this is the equation we get for the magnitude of AC square. So we can do the substitution for the square of the magnitude of vector AC in the equation for the magnitude of vector AG. So instead of AC square, we can write square. Now we can sub in the magnitude of AB, BC and CG as x, because that's what we assume to be the magnitude of the vectors AB and C, which is also equal to the side length of the cube. Now we can simplify this equation. So we can add the 3x square terms. So we get 3x square and we can apply the square root to both sides. So that will change the square of magnitude of AG to just magnitude of AG. So we get magnitude of AG is equal to 3x square. Now we can repeat this analysis for magnitude of vector BH. So for magnitude of vector BH, we'll analyze triangle BHD. So this is a right angle triangle and BH is the hypotenuse in this right angle triangle. So as per the Pythagorean theorem equation, Now, side BD is part of triangle ABD, and triangle ABD is a right angle triangle. So we can use Pythagorean theorem. So we get, so this is for triangle ABD. So magnitude of square equals the magnitude of BA square plus magnitude of AD square. Now we can do the substitution for the square of magnitude of BD. Now BA, AD and DH represent the side of the cubes. So their magnitude is equal to x. So we can apply square root to both sides. So magnitude of BH is equal to square root of 3x squared, because the square and the square root on the magnitude of BH get cancelled. So this proves that the magnitude of AG is equal to the magnitude of vector BH. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it and subscribe to Homework Help. Thank you very much and have a nice day. Bye.